know. I feel like the weather is almost too warm today. I walked the dog and I was like, this is too much. I don't think I can handle it, but it's my fault for wearing sweatpants. All right. So, oh, we got on the chat, Lurshi. Hello. Hope everybody is doing well. So I wanted to talk very, very quickly about our infographic project. So there's been a little confusion about what I exactly want from you. And so the project that we are doing, I want you to create an advertisement for a product. And it doesn't have to be a real product. To give you an example, a couple of years ago, one of the most memorable project ideas that I remember students coming up with was a literal brain in a jar. Like, it was a brain in a jar that could help you solve problems and basically offload your problems onto the brain in the jar. And they will actually get annoyed with me because the technical name was brain in a vat. So it was a brain in a vat. But the idea is that you need to take concepts that we have talked about in class and use those as opportunities to help you kind of sell and have people remember your product. So for example, what are some different ways that you could help people remember the name of your product? You could do things like the testing effect. You could quiz them at different points in the infographic, like, what's that name? It's this. You could repeatedly use the name and the motto to help people remember. So those are some different things that you can do. You can do things like use Gestalt principles in the logo or in the illustrations of your project. So some of the different Gestalt principles. You can talk, we're going to talk a little bit today about judgment and framing, and the way that you phrase or frame different kind of questions can also affect whether or not people want to buy your product. So you could say something like, it's 25% lean versus 75% fat. 25% lean tends to sound healthier than 75% fat, despite the fact that they have the exact same content. So these are just a few examples of some things that you can do, some cognitive psychology principles that we've talked about in this class that you can identify in your infographic to help you. So I hope that this makes a little bit more sense. Remember that you're designing a product and using these principles to help you sell the product. Does anybody have any questions right now about that? Yes, no, maybe? Well, how about this? If you do, and you don't think of them right now, but you think of them later, feel free to email me. I am always very, very happy to help you out with that. So we're going to go ahead and hop on to screen share. And we are going to continue our discussion of chess playing and expertise. But I promise, I think we're going to get done with it today, fingers crossed. Some of you are like, are we done with chess? Really quick too, I do kind of want to pop up the syllabus to see what's kind of on our horizon. Just a friendly reminder that exam 3 will post on Wednesday. I have almost completely written the exam. I will have it done by tomorrow, and I will have a study guide up for you on Wednesday. And so that's going to be due on the 18th. So we have a homework assignment that's due Monday, November 16th. I may give an extension for that because we haven't gotten to logic and reasoning at all. So I'll kind of keep that in mind. I may push that back, and I'll give you an update on what date I want that, probably by Wednesday at the very latest. So we're a little bit behind, but I will be uploading a Psychonomics blog post, Distangling Our Inner Schrodinger, a quantum account of order effects and the conjunction fallacy, which we are actually going to talk about this week. All right, so hold off on homework number 5. We're not there yet. I will push that back. Okay, so let's continue talking about chess. So the last time that we were here, we were talking about Ferdinand Gobet's template theory of chess. And so just as a reminder, this looks a lot like how we talked about scripts. So remember that scripts help us navigate our world by being very, very flexible. So if you go to a variety of different types of restaurants, you will be able to understand what happens at every restaurant, even if restaurants differ from each other. And a template is very much like it. It is a schematic structure that contains a fixed part called a core. That part never changes, and then variable information. So this is kind of like a chunk, but it's much more flexible, and a template tends to hold about 10 pieces. So here were the major predictions that Gobet's template theory had with respect to chess. So because we're dealing with a template, the chunks are going to be larger, but because the chunk size is larger, that also means that they're going to be fewer in number. Chess knowledge can be accessed very rapidly. Generally, experts are going to store precise locations on the board. Pieces that are close together should be grouped together and should be part of the same template. And then finally, this chess expertise is what we call domain specific. This means that just because you're really good at chess doesn't mean you're good at Monopoly. And just because you're good at chess doesn't mean that your IQ is high. So it's what we call domain specific, as opposed to something called domain general, which basically means that you do well across a wide variety of domains. And by the way, folks, I just wanted to let you know, I know that listening on Zoom is hard. I mean, I'd like more of you to be in person, but I know if you're not feeling well or if you're not here, I know that that's hard. So I wanted to let you know how much I appreciate how much you've worked to kind of push through this semester. And also, if you are having trouble focusing on Zoom, it's actually one of the reasons why I'm really glad that I started recording the live streams. So that way, if there's something that you kind of miss or had difficulty focusing on or didn't understand, you can go back and listen to it later on. So I just wanted to let you know how much I appreciate you. I know that this is not an easy time, and this has not been an easy semester, but you're doing, I think, what I see. Now, how you feel might be very different, but I can see you all pushing through, and I just want to let you know I'm really proud of you. Robin, I'm not going to move until you tell me you're good? Okay, I didn't want to push you. Okay, so the last time we were here, we finished up with evidence for rapid access of knowledge. Generally, we do find that compared to novices, expert players are a lot more likely to fixate on pieces that are relevant in a tactical sense. So very key attack and defense positions, rather than looking at irrelevant pieces that really are not critical to being able to do a particular play. One of the other ways that we have looked at this is with studies of what are known as blitz chess, which is basically a full chess game played in a period of 5 minutes. And research has actually found that the better you play at blitz chess, odds are pretty good the better you are at actual chess, indicating that expert chess players are able to access this knowledge very, very quickly. So let's talk a little bit about memory and the structure of these underlying templates. So research has actually found that compared to novice players, expert players do have a better tendency of recalling precise squares on the board. They are also better at evaluating attack and defense positions. And they're also better at recalling random configurations of pieces. And that's actually in contrast to what Chase and Simon actually found back in the 1970s. So chess players who have a really good working knowledge of chess actually do a better job recalling random chess configurations than novices do. So I want to briefly talk about medical expertise. So how do doctors and other medical experts make rapid and accurate diagnoses? So this can be incredibly important. So one of the things that we find, for example, a couple of years ago, and I don't mind telling you this, I actually had to get a mammogram. A couple of years ago, probably about 5 years ago, I ended up finding a lump in my breast. And it turns out that about 80%, nobody told me this before I found it. 80% of the lumps that you find, like a good majority of the lumps that you find in your breasts, are going to be harmless. They still want to check it out and figure out if it is an accurate if it's malignant or if it's benign. So here's what's really critical. A radiologist or whoever is viewing these scans needs to be able to make an accurate diagnosis. And this needs to be done very, very well. You have to have a lot of knowledge to be able to do this. And if you don't, there is the risk that you are unnecessarily frightening somebody who has a benign tumor, or worse, you are missing something that could be cancerous in somebody who is not aware of that issue. So expertise and knowledge in this domain is critical. So researchers have actually kind of looked at medical experts and radiologists, and they've tracked their eye movements for biopsy case slides. And what's interesting is that Krapinski and colleagues found in 2006 that fully trained pathologists spend the least amount of time examining the slide compared to people that have had less training or medical students, and they're able to extract more information from that slide despite spending the least amount of time looking at it. Additionally, Kundal and colleagues found in 2007 that expert doctors almost immediately are able to fixate on the cancer that is present. So they're capable of seeing things that if I looked at it, I am not a medical person, I am not a radiologist, I'd be like, yeah, that just looks like stuff. A doctor would be able to, somebody who's been spending a lot of time doing this would be able to focus on the cancer that's present. So now I want to move on to a little bit more of the work that Anders Ericsson actually did on expertise. And this is through the notion of what is referred to as deliberate practice. And one thing that I will mention is that the notion of deliberate practice is actually pretty controversial, not for any other reason than this at the bottom. This statement at the bottom is probably the most controversial statement, and we will address that in a minute. So Ericsson, Crampy, and Tesh-Romer back in 1993 looked at a wide variety of different types of experts. And I've heard his graduate students were looking at things like music experts, so these expert violinists, these expert instrumentalists, expert golf players. So looking at experts in a wide variety of fields. And Erickson and colleagues basically believe that this expertise is developed through what is referred to as deliberate practice. So the idea basically being that if you want to become good at something, you have to practice it. So the joke goes, how do you get to Carnegie Hall? Practice, practice, practice. So what is involved in deliberate practice? So if I want to be an expert tuba player, which I am not, what would it take to get me there? Would I basically practice my scales over and over and over again for 10 years until I developed it? No. That is not what deliberate practice is. Deliberate practice involves the following steps. So first of all, here's what's really critical. This has to be done at an appropriate level of task difficulty. What this means is that as I get better at a task, I need to make the practice more challenging. So if I want to become an expert basketball player, I do not spend the entire time just shooting free throws. That might be useful very early on, but it's also not going to make me good at much else. And if I never increase the level of difficulty, I'm not going to get there. So you constantly have to be kind of getting feedback and constantly changing your level of difficulty based on how well you do. The other thing that you need to do, so I mentioned the importance of feedback, and here's what's really critical. The feedback has to be what you need to do better next time or what you're doing right. You don't just go, hey, good job. Well, that's awesome. Tell me what I could do to fix it and get better. So we need clear, concrete feedback. There are opportunities to repeat the task. And additionally, there are opportunities for you to correct errors. So you need to be able to fix your mistakes. Now, here's probably the most controversial part about Erickson's theory of deliberate practice. And not all researchers agreed with him. Erickson believed that innate talent or ability was not required. Now, I would argue that some amount of talent matters. I could be a wonderful basketball player, but I'm pretty sure I'm not going to be joining the WNBA anytime soon. Why? Because I'm short. I'm not super short, but I'm not tall enough to play basketball. Additionally, you have to have some modicum of talent. You don't need a lot of talent. You don't necessarily need a lot of ability, but you need enough of it to be able to do it. If you're tone deaf, it's going to be very, very hard to make you a good singer if you can't even sing in key. And some of that can be trained, but some of it is also innate. So here's an example of deliberate practice that can really change your performance. So this is based off of research by Erickson, William Chase, and Steve Balloon. Thank you, allergies. So Steve Balloon, he is basically this person, SF, who was a student. And he spent 2 years practicing a digit span task. So remember digit span? With digit span, I give you a list of numbers, and you have to repeat them back in the order that you heard them. So SF basically spent 2 years practicing this task for an hour every single day. And it turned out that SF liked to run. And he had a lot of knowledge and data on running times. So he knew like what the world record running times were for different things. And he actually used his knowledge of running times to basically increase his digit span from 7 digits up to 18. And it gets even better. Now, at some point, the running times didn't really work when he practiced. So what he ended up doing was chunking items together and organizing them into a hierarchical sort of retrieval structure. You don't need to know what that retrieval structure is. But by the end of 2 years, SF was able to do digit span and recall a list of 82 digits. It can be done with practice and with increasing the difficulty. Right. Everybody good? Okay. Now, here are some potential issues that I've already kind of brought up with deliberate practice. Deliberate practice is not the sole factor for expertise, and innate talent absolutely plays a role. Now, one of the things from a scientific and behavioral design standpoint that's really critical here is that with deliberate practice, the experimenter is not controlling the practice. The expert is. So we are looking at something that is potentially correlational in nature. And if we want to have a better idea if deliberate practice works, we need to have the experimenter manipulate it and try it out rather than having the expert choose it for themselves. We don't exactly understand why individuals choose to, we don't understand why individuals choose to engage in deliberate practice. And additionally, this can be really hard to apply to broad, complex skills. So this works really well for chess. It works less well for things like writing, which are very broad skills and are very, very complex as well. All right, so we are done with talking about problem solving and expertise. Now we are going to talk about judgment. It comes for all of us. So we're starting talking about judgment and decision making. Today we are largely going to talk about judgment. We will talk about decision making later on in the week. I'm going to be asking you a lot about coin flips. Just be prepared. We're also going to talk about viruses, which, you know, I've been using virus examples for a while and now it feels like it's in poor taste, but I don't think it is going to be in poor taste, but these are examples that I've been using for a while. So let's first talk about the difference between what a judgment is and what decision making is. And part of the reason that I really love talking about judgment and decision making is that these are things that you do every single day and you don't even realize you're doing them. So judgment is drawing inferences about different situations and events. So this is all about how likely do you think this is going to happen? The goal of judgment is to be accurate. So the goal of judgment is accuracy. We're going to focus on the accuracy of these judgments when we research them. Now, decision making is going to be different. Decision making is when you have to choose between various options. And we'll be looking, and oftentimes when you make a decision, you are less focused on the accuracy of the decision, and you are more focused on the consequences of your decision. And when researchers study how people make decisions, they are also focusing on the consequences of those decisions. So I want to be clear. So a couple of years ago, I went to a conference and we were talking about choice behaviors. So here's something that might blow your mind. Do you realize that when and I'm just talking about one specific thing here. So we're talking about food decisions. The speaker said that we make hundreds of food-related decisions every day. And I know that some of you are kind of like, because I told this to my partner and he goes, "Are you sure it's hundreds?" I'm like, yes. What to eat, how much to eat, when to stop eating, when you're going to eat again. So when you're doing all of these different things, you are making hundreds of decisions every day. And probably for most of them, you don't give them a second thought. But we're going to start by talking about judgment research. I'm going to show you the scariest formula that you are ever going to see in this class. It's very mathy, which means I love it. Some of you might really hate it. Okay. So we're going to start with a problem. So I'm going to tell you a story about taxi cabs. So I think I kind of spoiled it a little bit, but let me see. But I forgot the slide for it, so I'm going to find it. Okay. So this is a story. And I want you to tell me what you think when I'm done telling you the story. So this actually comes from research by Daniel Kahneman, who's done a lot of research on judgment and decision making. So we're going to talk about cabs. We're going to talk about cabs. So here's how it goes. A cab was involved in a hit and run accident at night. Two cab companies, the Green and Blue, operate in the city. 85% of the cabs in the city are green and 15% are blue. The court tested the reliability of the witness under the same circumstances that existed on the night of the accident and concluded that the witness correctly identified each one of the two colors 80% of the time and failed 20% of the time. So the witness identified the cab as a blue cab, by the way. What is the probability that the cab involved in the accident was blue rather than green, knowing that this witness identified it as blue? So folks, it's a scary probability question. Throw out a number for me, please. So what is the probability that the cab involved in the accident was blue and not green? Anybody want to throw out a number?
Was there more blue than green?
There are 85% of the cabs in the city are green, 15% are blue. So what do we think? Somebody said it was a blue cab, and she's right 80% of the time.
Would that be wrong? Wouldn't there be more like 5 out of like 10, or like 6 out of 10 would be green cars, and like 4 out of the 10 would be like?
You're actually very close. So for those who can't hear, Robin's kind of bringing up the fact that there are more green cabs in the city than blue cabs. 15% of the cabs in the city are blue. So Robin has kind of suggested that the witness is probably incorrect and that odds are pretty good is it might be 40%. But the probability that it is a blue cab is about 40%. Now, she's not wrong. Now, the numbers might be off, but I think paying attention to the fact that there are more green cabs in the city than blue cabs is important. Now, how many of you only focused on the witness? How many of you only focused on the witness? Because that's what a lot of people tend to do. People go, well, she's right most of the time. She mentioned a blue cab. It must be a blue cab. But we don't pay attention to what we call the base rates of occurrence. So I'm going to show you a really scary slide. This is what is known as Bayes' theorem. So one of the things that we find is that new information can change our judgments. If you hadn't heard anything about a witness, or rather, if you hadn't heard anything about the witness's accuracy, so we know that 85% of the cabs in the city are green, 15% are blue, and a witness identified it as blue. That would have been fine. Most of us would have figured out that odds are pretty good that the witness was wrong, and because there are more cabs in the city, the chances of it actually being a blue cab are pretty small. But once we start getting information about the witness's accuracy, we start to focus more on that and less on the base rate of occurrence. Now, this is a scary theory. I do not require you, I'm never going to make you do math on this, I promise. But here's kind of what we're looking at here. So we have some hypotheses given the data. So this weird little symbol here, so we've got two hypotheses. One hypothesis is that the cab was blue. The other is that the cab was green. So this little symbol here, so let's go ahead and say that hypothesis A is that the cab is blue. So this is the probability that the cab is blue given the data. This is the probability that the cab is green given the data. And you calculate this by doing a couple of different things. You have the prior odds of each hypothesis being correct without the data. And then you have to multiply it based on what we call a likelihood ratio. So what is the probability that the data would shake out this way given each of these hypotheses? So all of this scary thing, and it is, Dr. Gilchrist has taken several classes on Bayes' theorem and has calculated likelihood ratios, and she does not recommend it. It is very mathy. But all of this scary little formula to basically say that we have to assess the prior odds of occurrence or the base rate of occurrence before we obtain the data. So we need to assess the prior odds before the data are obtained. So if you want to figure out if the cab is more likely to be a blue or a green cab, it's important to look at how many cabs there actually are in the city. So that's what Bayes' theorem basically says. You have to know the prior rate of occurrence before you can make that kind of a judgment call. So there is so one of the things that Bayesian researchers often critique research psychologists for is that we pretend that we don't know what the prior rate of occurrence is when we do hypothesis testing. So there is an entire field of statistics known as Bayesian statistics that's basically all about figuring out what the prior odds of those things are. And you can do a lot of really cool computer modeling with it. I have tried it. I have also been told that when it comes to things like that, I am like a person going after a fly with a sledgehammer rather than a fly swatter. So let's go back to this taxi cab problem. So we already kind of talked about this. So what's the probability that the cab is actually blue? Robin gave us a number of about 40%, and she's not actually that far off. The correct answer is actually closer to about 29, actually it is about 41%. Well done. So even if the witness states that the cab involved in the accident was blue, the probability that that's true is only about 41%. Give yourself a pat on the back. Probability is a scary thing. It is my least favorite part of statistics. So here's how we figure it out. So the odds ratio for this is 12 to 17. So here are the rates of occurrence. So we have 15% of the cabs that are blue. We have 85% that are green. Here, we have about 80% that the witness is correct and 20% that she is not. So when she identified the cab as being blue, there's an 80% probability it is in fact blue, but there's a 20% probability that it's green. So when you multiply these together, you get 0.12 over 0.17. So when we calculate the percentage for blue cabs, we do this 12% over 12 plus 17, which is 12 over 29, equaling 41%. Thus, there's a 59% probability that it's green. Don't worry, you will not be asked to math these things, I promise. The overall thing that's really important to pay attention to here, though, is you've got, if you only focused on this, and some people do, they would say there's an 80% chance that she's correct because they're only looking at her accuracy. But you have to look at the base rates of occurrence as well. So why do so many of us get this wrong? We don't take the prior odds into account. So when we do take the prior odds into account, this is what is referred to as base rate information. It is the relative frequency of an event or of an attribute. So in the cab example, green cabs are more common, but we forget this when we're trying to figure it out. Oh, that's kind of, well, that's not funny, but the Pfizer vaccine reported good news and Zoom stock took a nosedive. That's, I gotta say, Zoom has been incredibly helpful, but y'all, I can't wait for the day that we don't have to. And it will get there sooner rather than later. It will get there eventually, I promise. I can't say about next semester, but let's keep our fingers crossed for fall. Very crossed. I can't really cross my fingers like multiple times, but I've got them crossed 3 times over. Okay, so here's another example, and you don't need to write this down. Those of you that are zooming in, I would love if you would put in the chat which of these you think is more likely. So Jack is 45 years old. He's married with 4 children. He's generally conservative, careful, and ambitious. He shows no interest in political or social issues and spends most of his time on his many hobbies. These include carpentry, sailing, and numerical puzzles. So what is the probability that Jack is a lawyer, and what is the probability that Jack is an engineer? And by the way, by conservative, we mean traditional because he's not political. We are not talking about politically conservative. That's a little bit different. So in the chat, tell me if you think Jack is more likely to be a lawyer or he's more likely to be an engineer. All right, what we got? Let's see. Engineer. Okay, how are we feeling here? Engineer, engineer, engineer. Okay, why did y'all pick engineer? I think it depends on the type of lawyer, though. Like if they're involved in intellectual property law, like copyright and stuff, they may not actually be all that interested in politics unless it specifically has to do with copyright law, for example. So most people Let me see. So I would suspect that somebody who likes to do carpentry, somebody who likes to do puzzles, that is probably somebody who really likes to exercise their mind. That might make them an engineer, thus being conservative, careful, and ambitious, and no interest in political or social issues. I do think we do have that stereotype that lawyers are more often involved in politics, just because many of our politicians initially started out as lawyers. So most people are going to say that Jack is an engineer rather than a lawyer. But here's what's kind of interesting. If I give you certain amounts of base rate information, that can change. So we typically do not think about the frequency. So participants were told that Jack's description was selected from 1 of 100 descriptions. 50% of participants were told that the descriptions were mostly made up of lawyers. The other 50% were told that it's mostly made up of engineers, and yet everybody ignores the base rates and focuses on the fact that Jack fits a stereotype of engineers, and thus we have this 90% probability that Jack is an engineer. You don't actually know that. So the example that I give in Gen Psych is that I ask people, this is a person who's not really interested in real world issues. They're very introverted. What's the likelihood that this person is a salesperson or a librarian? Most people pick librarian because it fits the stereotype, despite the fact that if we look at the base rates of how many salespeople there are out in the world, that person's probably a salesperson, not a librarian. But we focus on how well it fits the stereotype, and we ignore the base rates of occurrence. So when we're trying to judge whether or not Jack is an engineer or a lawyer, we're using a heuristic to make a judgment. And this was largely based off of the work by Daniel Kahneman and Amos Tversky. And they both earned the Nobel Prize for their efforts. There is no Nobel Prize in psychology, but there is a Nobel Prize in economics. And quite a few, well, not quite a few, but several cognitive psychologists have actually earned the Nobel Prize in economics for their work. So that includes Kahneman, Tversky, as well as Herb Simon. They have all earned the Nobel Prize, and they're also cognitive psychologists, which is kind of cool. So a heuristic is often what we're going to use to make a judgment. And a heuristic is a general rule of thumb that we can use to help us make a judgment or draw an inference. Now, heuristics are very quick. They're very quick, fast ways to solve problems, but they're not 100% accurate. And as a result, we can occasionally find that we develop some systematic errors as a result. So generally, the quicker something tends to work, odds are pretty good it's going to work most of the time, but you're also going to make very characteristic errors as a result. So when we judge that Jack is more likely to be an engineer because he fits our idea of what an engineer is, we are falling prey to what we call the representativeness heuristic. And this is the assumption that typical members of a category are going to be the most frequent. So we're going to focus on how well something fits a prototype or a stereotype. And oftentimes we're going to find that along with this, so we assume that typical members of the category are most frequent. Additionally, an event that is similar to most of the others in the population is thus representative of the whole. Remember, people are not monoliths. I think if you were viewing election results and were looking at certain kind of demographics, you would very, very quickly see from the demographic breakdown that people that you assumed were monoliths because they voted in certain ways or certain expected ways, people are not monoliths and groups are not monoliths. All right. I will wait just a minute and take, well, my soda's empty, so I guess I'll keep going. Okay, so here's one more problem. So we're going to talk about Linda. Linda is 31 years old. She's single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. So I want you to judge the probability that Linda, 1, is a bank teller, 2, is a feminist, or 3, is a feminist bank teller. Which of those do you think is most likely? So in the chat, tell me what you think is most likely. So bank teller, feminist, or feminist bank teller? Oh. Anyone? Oh, we got one in the chat. Okay, feminist, okay. Feminist, okay. Did anybody here think she was more likely to be a feminist bank teller? That is okay. That is also wrong. Okay, so what we often tend to find is that for a lot of people, they're a lot more likely to say that Linda is a feminist bank teller than either one of these on their own. And here's what's really critical. So we have one characteristic, we have another characteristic. When we're talking about judging probability, when you put these together, you have to multiply them, which means that the probability of her being a feminist bank teller is going to be smaller than either one of these on their own. She's more likely to be a bank teller, or she's more likely to be a feminist. But a lot of people think she's most likely to be a feminist bank teller. And this is what is referred to as the conjunction fallacy, which is going to be included in your blog posts that I'm going to put on e-learning after class. So the conjunction fallacy is the belief that a combination of 2 events is more likely or is more probable than one of them on its own. In the Linda example, people tend to rate being a feminist bank teller as being more probable than either a bank teller or a feminist. And it makes sense. She fits the profile. She fits the profile, but from a statistical probabilistic standpoint, this is less likely than just bank teller or just feminist. And that is today's teaching you stats and probability. Don't worry, there will be more of these on Wednesday. But I hope you have a wonderful day, and I really do mean it. I know it's been a hard semester. I appreciate everything you're doing. If you're quarantined, I got my fingers crossed for you so that you stay safe. Make good decisions, folks. Keep washing your hands, and I will see you on Wednesday, folks. Take care.